Okay, so network address translation, also known as NAT, and port forwarding. So I'm going to cover these together because they are very similar and basically opposites of one another. So this is a private network. So this could be your network in your school. And let's say this is your device, device A, which is a phone. And this is another device, device B, which is a computer. So both of these on this school network have unique IP addresses. And on this school network, there is the school network router, which has a private IP address of this. Now, recap what private addresses are. They are addresses that are unique only to this network up here, but not unique to the entire internet. So you could have this address 10.0.0.6, but that address can exist 10.0.0.6 uniquely on the public network. Okay, so you at device A in your school want to send to a device C on the public network with this address. So where does NAT come into play? So if you want to send data to that device, you have to go to your home router. And what that will do is that will add this IP address 10.0.0.5 to the network address translation table. Okay, and the port number of what application sent it. So let's say device A sent with application having a port number 100. Then we will add this to the NAT table. And because we are sending it to the router will have a public IP address as here as 20.0.0.5. And NAT will assign a port number, a new port number. So this could be port 1000 as an example. So now you have an entry in your NAT table. And this has basically created a mapping. So from A to R1, it's 10.0.5 with port 100, and then to go backwards using this side, we have to go this way, and we have to send it to 20.0.0.5 with port 1000. So that is basically the mapping that's created. I'm going to show you how that works. So you send a packet to R1, R1's going to send it to R2, and then R2 to the device on C. Now, how do you get a response back? So where does C have to send it to? C's not going to send it to your private IP address because it doesn't know that. But what it does know is that this router sent a packet to it. So it's going to send it to the public address on R1. So C will send its response back, and it's going to hit 20.0.5, and it will have included a port number, and that port number is going to be port 1000 because at this router, when we initially sent it to the C, we had a source of 20.0.0.5, and the port source, so that's source IP, source port was 100. Or not 100, sorry, it was 1000 because we're using the router's assigned one through NAT. And so now when C sends to this address with port 1000, NAT's going to go, okay, so this router is going to say, okay, so I've received a packet here with destination 20.0.0.5 and the destination port is 1000. The router will look in the NAT table and the entry that it already created and say, okay, so something is coming for port 1000 and for IP address this What does that correspond to? Well, it corresponds to a device with this IP address and this port. And what is that? Well, that is simply this device. And as we said, port forwarding is very similar to NAT, but handles the incoming mappings. So NAT was all about when we go outward and we send a packet, what mappings are we going to create? Port forwarding is all about when we have incoming packets, what mappings will be created. So let's say we have in our port forwarding table, we have device 10 point this and this device IP address as well. So this is for device A, then we have device B's IP address here. And let's say we assigned applications on each device, or they had port 400, port 500. Now, what is going to be the IP to communicate with these devices? Well, it's going to have to be the public IP because these devices are protected on the private network. So it's going to be the IP address of our router, the public one. And what we can do is we can create unique mappings like this. So now we're all about incoming traffic. So let's say we are now device C and it's going to send a packet with destination IP address as the router's public and destination port as 1000. Device C will send to the router, and then the router will send it to the IP address in the destination here. And a port number is included. So what the port forwarding table is going to do, or the router is going to look at the port forwarding table and say, okay, you sent with destination port 1000, which corresponds to the device with IP address this, and the application on the device with port number 400. So the router will forward it to device A and the port number. However, what happens if the device C had the port number destination as 2000? Well, I'm sure you can see it's still going to go to R2 and then R2 to R1. And now the router is going to look in the port forwarding table and say, okay, you had port destination as 2000, so I need to forward it to device with this IP address and the application on that device with this port. So it's going to forward it to this device.